Solving other equations. In this video, we're going to learn how to solve any kind of equation. The first thing we're going to start is with solving a radical equation. So a radical equation includes a radical symbol. And the equation, we have to isolate the radical on one side and then square both sides and check our solution. So let's look at the first example. So we're going to start by squaring both sides. Now we can check the solution. It's very important in solving a radical equation to check the solutions. In the second example, already we have the radical on one side, so we're going to start by squaring both sides. So for x, by subtracting 7 on both sides, and now we can check our solution. So we got true statement in both examples, so our solution is correct. Another example, also the radical is already isolated on one side, so we can start by squaring both sides. Simplify. Now we're going to use the zero property to solve for the solutions. It's very important to check your solution. So the only solution is x equal -2. Another example. So keep in mind we need to isolate the square root. So we're going to start by adding 1 on both sides. Now the radical is already on one side, so we're going to square both sides. Now the left hand side everything cancel, and the right hand side we need to use the foiling method. Now we need to set everything equal to 0. We're going to use the zero property, and by using the zero property we got x equal -2 or x equal 1. Keep in mind we're not done yet. We need to check the derived solutions. So when x equal -2 we got a false statement. Now when x equal 1 we got a true statement. Therefore x equal 1 is the only solutions. Now solving by substitution, we need to use u or any kind of letter you want, and we're going to set it equal to the quantity attached to b. For example, let u equal x squared. So we have an equation x to power 4 minus 5x squared plus 6 equals 0. So we're going to let u equal x squared. Therefore u squared equal x to power 4. Now we're going to change this one in terms of u. Now this one is a quadratic equation that can be factored into u minus 3 times u minus 2 equals 0. We're going to use the zero property to solve it. Therefore we get u equal 3 or u equal 2. But keep in mind we're solving for x. So we're going to take out u and substitute it by x squared. Therefore the solution is as such. Another example, we need to solve for x in x to power 4 plus 3x squared minus 4 equals 0. So let u equal x squared. Therefore u squared equal x to power 4. Therefore my equation will change into u squared plus 3u minus 4 equals 0. This can be factored as u plus 4 times u minus 1 equals 0. Now we're going to use the zero property. Therefore we got u equal -4 or u equal 1. But keep in mind we're solving for x. Now we're going to take out u and substitute x squared. Therefore, the solution is as such. Another example where we have to use substitution. So we're substituting a minus 2 for x. Therefore, my equation will change into 2x squared plus x minus 21. And this can be factored as such. We're going to use the zero property. Therefore, x equal 3 or x equal negative 7 over 2. Now we're going to replace x for a minus 2. Therefore, the solution is negative 3 over 2 and 5. Keep in mind we're solving for a. Absolute value equations, they have absolute value. So keep in mind the absolute value of any number is the distance of that number from 0, and the result is always positive. So if we have absolute value, the quantity inside that absolute value could be negative or positive. So if we have the absolute value of x plus 3 equal 9, so x plus 3 could be equal to plus or minus 9. So we have two equations. Now solve for x. Therefore, the solution is 6 and negative 12. Another example, we need to simplify first. So we're going to start by adding 2 on both sides, then divide by 5 on both sides. Now we're going to set x plus 2 equal to plus or minus 2. Solve for x. Therefore, x equals 0 or x equal negative 4. Now we have exponents. So we have x to power 1 over 3 equal 2. Therefore, we're going to raise both sides to power 3, which is the reciprocal of 1 over 3. Therefore, x equal 8. Another example, we need to raise both sides to the reciprocal of 2 over 3, which is 3 over 2. Simplify. Therefore, x equal plus or minus 8. Keep in mind, if the numerator is even, we need to write plus or minus. Another example, now solving by grouping. So we have a polynomial of 4 terms. Every time we have a polynomial of 4 terms, we need to solve by grouping. So we're going to divide my polynomial into two groups. We're going to factor the first group, and we're going to factor the second group. Now, I notice in the two groups I have something in common. So we're going to factor this one out. And then from the first group, we're left with x squared. And from the second group, we're left with plus 1. Now we're going to use the zero property. Therefore, the solution set is as such. Example where we have to solve by grouping. So we divided my polynomial into two groups. We factored the first group and we factored the second group. Now I noticed there is something in common between the two groups. So we're going to factor this one out. Now from the first group, we're left with x cubed, and from the second group, we're left with 8. Now we're going to use the zero property. Therefore, the solution set is as such.